Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P2400-17 indicates an issue with the evaporative emission leak check pump control circuit in the 2023 Honda CR-V. This code specifically highlights a high voltage condition in the circuit that controls the evap leak check module vacuum pump. The powertrain control module, PCM, monitors the output voltage from the evap leak check module vacuum pump and triggers this DTC when the voltage is found to be abnormally high while a signal is being sent to activate the pump. The leak check pump is a critical component in the vehicle's evap system, which prevents fuel vapors from venting to the atmosphere, thereby reducing emissions. Understanding the role of this component is essential for effectively diagnosing the issue. If this DTC is illuminated, it indicates a possible malfunction in either the circuit or the evap leak check module itself, necessitating a comprehensive diagnostic approach. The P2400 diagnostic trouble code signals a high voltage condition detected within the control circuit of the evaporative emission leak check pump. At the heart of this error code lies the evap leak check module, which is responsible for monitoring and maintaining the integrity of the vehicle's evaporative emission system. Located near the fuel tank, this module utilizes a vacuum pump to perform leak checks, ensuring that any fuel vapor leaks are identified and reported by the powertrain control module, PCM. When the PCM outputs an on signal to the evap leak check module and detects a high voltage on its output instead of the expected lower voltage, it triggers the P2400-17 code. This situation can lead to improper fuel vapor handling, raising concerns about both emissions and the overall efficiency of the vehicle. Recognizing the exact role of each component is essential for narrowing down the source of the problem. Diagnosing the P2400-17 entails exploring a few distinct yet common causes. First on the list is the possibility of an open wire in the circuit leading to the evap leak check module. An open wire can disrupt the proper voltage signaling, causing the high voltage condition that triggers this code. Next, grounding issues can also lead to erroneous electrical readings. If the ground connection to the module is compromised, it may result in unexpected voltage levels. Finally, the evap leak check module itself may be at fault. This component could be damaged or malfunctioning, leading to failure in its operation and the subsequent high voltage detection by the PCM. Each of these potential causes highlights the need for a thorough inspection process to pinpoint the exact issue at hand. When the P2400-17 code is triggered, several symptoms can manifest, primarily focused on the vehicle's emissions and performance. The most immediate symptom you may experience is the illumination of the check engine light on the dashboard. This warning indicates that the PCM has identified an issue that requires attention. Additionally, if the vehicle undergoes an emissions testing procedure, it may fail due to the malfunctioning evap system, potentially penalizing the vehicle's operation in regions with strict emissions regulations. Another less obvious symptom may include the presence of a noticeable fuel odor, suggesting a leak or malfunction within the evaporative emission system. Recognizing these symptoms allows drivers to take proactive measures in seeking necessary repairs, which ultimately helps in maintaining both vehicle performance and environmental integrity. The first troubleshooting step for addressing DTC P2400-17 involves putting the vehicle into the on mode, which activates the electrical systems without starting the engine. Here, the next critical action is to perform the Honda Diagnostic System HDS evap leak check module test. This test assesses the functionality of the evap leak check module and provides insights into whether it operates as intended. Upon completion of the test, Closely examine the results. An OK response suggests a functional system. However, if the results indicate failure, it confirms that the problem is duplicated. This first step is fundamental in establishing a baseline understanding of the EVAP system's functionality and aids in navigating subsequent troubleshooting measures systematically. The second step in the troubleshooting process for DTC P2400-17 requires a careful inspection of the external circuit involved with the EVAP leak check module. Specifically, technicians must perform an ELCMP, or Evaporative Leak Check Module pump, and GND, or ground wire, inspection to ensure there are no open wires within the circuit. Troubleshooting at this stage involves visually checking for signs of disconnection, damage, or corrosion that may cause interruptions in the electrical flow. Any identified break in continuity will directly affect the module's ability to function, leading to high voltage conditions observed by the PCM. Hence, confirming that these wires are intact and properly connected is essential before advancing to potential component replacements. In the third step of addressing DTC P2400-17, the focus shifts to inspecting the continuity of the ELCMP connector and the PCM connector B. Disconnect the EVAP leak check module connector and the PCM connector to facilitate a clear examination. It's crucial to ensure that both connectors have female terminals that are free from corrosion, damage, or any debris that may hinder solid electrical contact. Utilize a multimeter to measure resistance, confirming that it reads less than 1 ohm for both the ELCPM and ground connections. If readings exceed this level, it indicates an issue within the circuit, necessitating further exploration or repairs. If the readings are normal, but the DTC persists, it likely points towards a failure in the EVAP leak check module itself, warranting further testing or replacement. Once repairs have been made for the DTC P2400-17, it is crucial to conduct a final repair verification step to ensure that everything functions correctly. Begin by clearing the diagnostic trouble codes, DTCs, from the powertrain control module, PCM, resetting the system and eliminating any error messages from the dashboard. Following this, it is recommended to perform another EVAP system test to ensure that the repairs have resolved the initial high voltage condition. During this test, the PCM should monitor the operations of the EVAP leak check module and confirm that it behaves as expected without triggering any new codes. Achieving satisfactory test outcomes demonstrates that the repairs have been successful and the evaporative emission system is working effectively, preparing the vehicle for further road tests. Preventive maintenance is essential in minimizing the risk of encountering the P2400-17 DTC in the future. Regular inspections of the EVAP system components will help identify any wear or damage that may lead to electrical faults. Furthermore, monitoring the system's performance offers drivers insights into how well it is functioning and allows for early detection of abnormalities. Ensuring that all electrical connectors associated with the EVAP leak check module are kept clean and securely fastened is also vital in providing accurate electrical signals while avoiding short circuits or disconnections. Adhering to these best practices can significantly prolong the life of the EVAP system and maintain emission standards to ensure compliance with vehicle regulations. In summary, addressing the P2400-17 diagnostic trouble code requires a comprehensive understanding of both the EVAP leak check module and its operational context within the vehicle. Recognizing the roles of the relevant components, such as the PCM and the circuitry involved, is critical for efficient problem resolution. identifying potential causes like open wiring and faulty modules ensures that no area is overlooked during diagnosis. Equally important is the adherence to the outlined troubleshooting steps, as following these methodically facilitates a thorough exploration of the issue. Lastly, implementing preventive maintenance strategies can help maintain a healthy EVAP system, reducing the likelihood of future errors and preserving vehicle performance. Please like and subscribe to the channel. See you next time.